Hi everyone. Today I'm going to do a video lesson since I'm not here. I want to start with a little bit of review. And I know I've been so overkill with this. But we've been talking about moles, mass, and representative particles. And we should know at this point that 1 mole is equal to 6.02 times 10 to the 23rd representative particles. And again, depending on what the substance is, these particles will change. If it's an element, we call them atoms. If it's a covalent molecule, we call it molecules. If it's an ionic compound, we call it compounds. If it's a charged ion, if it's a charged element, we call it an ion. We also know that 1 mole is equal to X molar mass, okay? And again, we get this X from the periodic table. Okay? With that being said, again, this is all review. I just want to do like a few examples of going from moles to mass and moles to particles, or the opposite way around. So if we have something like how many moles are in 114.82 grams of indium, how many representative particles are in this sample? And we'll also name the representative particle too. The first thing we always want to do is start with our given. And our given is going to be a number, a unit, and a substance. Okay? So automatically, we're going to start with 114.82 grams of indium. And indium is on the periodic table. It's just an element. Okay? We want to go from grams to moles. So we need to find some conversion between grams of indium to moles of indium. Okay? And we know that 1 mole is equal to the molar mass of indium, which is on the periodic table. It's just the atomic mass. 114 grams is 1 mole of indium. My grams are on the top here, and I want to get rid of them, which means I have to put grams on the bottom. Okay? We're just going to put our conversion factor in this dimensional analysis table. And I'm going to put 1 mole on top, because that's what I want to end up with. Okay? 114.82 divided by 114.82, we have 1 mole of indium. Okay? First question is done. Our second question, we already have the moles of indium, so we can just do 1 mole of indium, 6.02 times 10 to the 23rd, atoms of indium. Because indium's an element, those representative particles are going to be atoms. And again, 1 times 6.02 times 10 to the 23rd. Very simple example, but effective because we were able to do both of these just given 1 number. Again, there's a relationship between everything that we're doing here. Let's do a couple more examples where it's not just 1. Let's do how many moles are in 40 grams of H2O. first things first, we're always going to start with what we're given. And we're given 40 grams of H2O, a number, a unit, and a substance. Okay? We're going from grams to moles. So we know that there must be a relationship between moles of H2O and grams of H2O. And again, same thing that we just did. We need to find the molar mass of water, which is 18.01. And I'm just rounding here. And the way that I found this was it's on the periodic table. And again, I'll write that pretty. We should know how to find molar mass. This shouldn't be confusing to us. We look on the periodic table, add hydrogen, we add that to the numbers, we add that to the atomic mass or the molar mass of oxygen, okay? We do 40 divided by 18.01. It should be around 2, in this case it's 2.22 moles of water. Okay, let's do another example. And let's do how many moles are in 4.3 times 10 to the 22nd molecules of H3PO4. Notice how there's nothing here that has to do with grams or mass. We're given 4.3 times 10 to the 22nd molecules of H3PO4, and we're asked to go to moles. Okay? So there is nothing about mass. However, we know that 1 mole of H3PO4 equals 6.02 times 10 to the 23rd. This is covalent molecules of H3PO4. Again, 1 mole of anything equals 6.02 times 10 to the 23rd of anything. So we're going to put 6.02 times 10 to the 23rd molecules of H3PO4 is equal to 1 mole of H3PO4. This equals 0.071 moles of H3PO4. If you need to know how to put this into your calculator, the way that you use that notation, there's a video on the topics page for you, which I highly recommend that you look at. And finally, how many grams are in 4.65 times 10 to the 33rd ions of Ca2+, okay? Again, always start with what you're given. In this case, we're given 4.65 times 10 to the 22nd, times 10 to the 33rd ions of Ca2+, okay? We cannot go directly from ions to grams. We first need to go to moles. And we know that in 1 mole of Ca2+, we have 6.02 times 10 to the 23rd ions of Ca2+. And the reason I put ions on the bottom is so they cancel. Now, we're still not in grams. We need to go all the way to grams. And I think 1 mole of calcium is 40.08 grams of calcium. And again, these charges don't affect the mass. We would just go to calcium on the periodic table and just use that mass. The charges don't really make a difference. They don't make a difference at all. The way that we do this math is we take 4.65 times 10 to the 33rd, divide it by 6.02 times 10 to the 23rd, multiply that by 40.08. We should get 3.10 times 10 to the 12th. And of course, grams of Ca2+. Okay? So this is just review of what we've been doing so far. What we're going to go into next is a little bit more complex. It is something called stoichiometry, which we've done. And the definition of stoichiometry is the section of chemistry that involves using relationships between reactants and products in a chemical reaction to determine desired quantitative analysis. What we've been doing so far is we have been, our review. What we've been doing is we've been going from moles of some substance, let's just call it X, to mass of X. Or we've been going from atoms of Y to moles of Y. In this case, we have not changed substances. Stoichiometry is a way to calculate moles of different substances. Okay, so, and this is just a very brief example. I'll do multiple examples. Okay, if we have X plus Y goes to Z, and let's just say when we're balancing this is 3, 2, and 5, let's just say. What this tells us is that we have 3 moles of X, 2 moles of Y, and 5 moles of Z. So our ratios is that for every 3 moles of X, we need 2 moles of Y. For every 3 moles of X, we need 5 moles of Z. For every 2 moles of Y, we need 5 moles of Z. And let's look at an example to kind of help us out with this. And again, we've done this part before. I'm going to introduce one other new thing. Let me scroll all the way up. Let's do our example. Let's use an actual equation here. Let's do rubidium phosphide decomposes into rubidium plus phosphorus. And again, this equation's unbalanced because we have 3 rubidiums here and 1 here, so we're going to put a 3 here. Now we're going to look at exactly what I just told you. We're just going to give it a name. These are molar ratios. These are the numbers, or the number of moles in a ratio between the substances in a balanced chemical reaction. So, based on our balanced chemical equation, we know that our molar ratios are as follow. For every 1 mole of Rb3p, again, I'm using 1 mole because there's a 1 in front of this, our ratio is 3 moles of, and the way that I got that is there's an invisible 1 right here. That's the molar ratio for this compound. There's also this compound here, which has a 3 as its molar ratio. So for every 1 mole of rubidium phosphide that we use, we're going to make 3 moles of rubidium. For every 1 mole of rubidium phosphide, sorry, I didn't write mole, we make 1 mole of phosphorus. And for every 3 moles of rubidium that's made, we make 1 mole of phosphorus. Okay? I know it seems a little bit complex. It's actually very simple. But remember, we can only do this in moles. If we're doing this in any other type of unit, we've done something incorrectly. Because you can only do this in moles. You can't do this in grams. You can't do this in ions. Okay? So, let's do an example here, and then I'll do 2 more examples. How many moles of phosphorus are produced if 7 moles of rubidium are also produced? So, we're always going to start with what we're given. 7 moles of rubidium. Rubidium is up here. We are trying to find moles of phosphorus. So the relationship that we're looking at is between rubidium and phosphorus, which is a 3-to-1 ratio. So we're going to put 3 moles of rubidium on the bottom, 1 mole of phosphorus on top. And once we do that math, you can just leave it as a fraction just for now. But you should have 7/3 moles of phosphorus, should be like around 2 point whatever. Finally, last question of the worksheet. Let's look at the decomposition of glucose. We have C6H12O6 which is glucose, and that decomposes into C2H5OH, which is something called ethanol, plus CO2, which we know as carbon dioxide. Okay? We need to put a 2 here because, and now we're balanced. Well, to balance the equation. So let's start with an easy question first. Okay, we have our balanced chemical equation. We know our molar ratios are 1, 2, and 2. Let's say our example says if 17.5 moles of ethanol were produced, how many moles of glucose were used in the beginning of the reaction? A lot of times, I don't know if I spelled that right. A lot of times, stoichiometry is able to tell a little bit of a story, okay? This reaction says that we start here and we end here. We end with these two, but we started with glucose. After glucose decomposes into ethanol and carbon dioxide. What's really nice about stoichiometry is we know that we ended the reaction, and when we looked at how much ethanol we had 17.5 moles. Okay? The question's asking us, well, if we had 17.5 moles of this, how many moles of this did we start with? And again, you cannot go wrong with starting with what you're given. 17 moles of C2H5OH. There has to be a relationship between moles of C2H5OH and moles of C6H12O6. Okay, so giving us moles, it's asking for moles of glucose. The relationship is the molar ratios. Okay, 2 moles of ethanol, 1 mole of glucose. All I did was put that into my mathematical equation. The question is basically 17.5 divided by 2, which gives us 8.75 moles of C6H12O6. Okay? I cannot tell you how complicated people make stoichiometry. It is one of the easiest things if you know that you have to use molar ratios when you're going from moles of one substance to moles of a completely different substance, okay? If it asks you for mole mass of the same substance or grams of the same substance, you don't need to use stoichiometry. You don't need to use molar ratios. But when you're going from one substance to a completely second, third, fourth, fifth substance, you're going to need to use stoichiometry. There's no other way to do it. Finally, the hardest question of the lesson so far is, let's use the same equation up here. Calculate the mass of ethanol if 5.00 grams of glucose were used. What this question is saying now is we use 5 grams of glucose. How much ethanol did we make in mass or in grams? The way that we do this is, and again, we have 5 grams of glucose. we're asked for mass of ethanol. We're switching substances. The problem is we have to get glucose to moles first and then go to moles of ethanol. Okay, I'll write this out a little bit better. So what we're trying to do here is we're in grams of glucose, and specifically that's 5 grams of glucose. We then need to go to moles of glucose. We do this by finding molar mass. Then we're going to go to moles of ethanol, which we're going to use molar ratios or stoichiometry for this. And then we're going to go to mass of ethanol. And we're going to do this using molar mass. So if we put this all together, we're going to do 5.00 grams of C6H12O6, which is what the problem gave us. The molar mass of glucose is 180.16. And all I did was I just added everything that's in glucose, C6H12O6, I just added all of that together. 1 mole of glucose. These cancel. We have 1 mole of glucose makes 2 moles of ethanol. Notice here is when I switch substances. This is so important. We switched substances right here. Now we're no longer in glucose, we're in ethanol. And then, of course, we're going to go to mass of ethanol. So 1 mole of ethanol is 46.07, I think, grams of ethanol. And that's C2H5OH. If we did all this math right, we should get 0.00121 grams of C5H5OH. Okay. There's a worksheet for you to work on now. I'll post these notes. We will review when I get back. Try your best on the assignment, and thanks for watching.